Hello, hello, and welcome to BC Calculus with Henry Lombino. Alright, so we're going to be looking at 13.2, chapter 13.2, which is vectors in general. So, and this is not your standard vectors, these are going to be vectors in 3-space. Luckily, however, the problem we're looking at right now is not in 3-space, so that makes it a little bit simpler, but just a little bit. Alright, so let's look at what we got here. We got number 17 here. A large ship is being towed by two tugs. A larger tug exerts a force which is 25% greater than the smaller tug and an angle of 30 degrees north of east. Which direction must the smaller tug pull to ensure that the ship travels due east? Okay, so to start this out, we're going to draw a little diagram here, just to kind of, because this is one of those things where you really want to draw a diagram before you start so you can really get an idea of what it's asking you for. So I'll do that right now. Okay, so here's our diagram here. Now, just to kind of explain it, so you can see we have this right here is the vector, the larger tug, which is exerting the greater force, which is which is v, which is the smaller force, times 1.25, which is 25% greater than v, and it's going at 30 degrees north of due east, which is the center line. Now this other one is the force that the other tug is going to be from. We don't know the angle, so I've just set it as theta, and then it has a vector velocity of v. So nice thing to know is that we actually are not going to be. We do not need the magnitude of v. We don't need to find that. We're just looking for the direction. So what all we're looking for is theta. This is what we're looking for right now. So that's what we're going to be looking for in the problem. So let's look at this. So okay, so what do we know? So this is actually not the greatest setup actually right now, because we're going to want to add these two vectors together, and the way they're going to add up is they're going to equal this center line right here. So let's make a different diagram that adds these up. And the way you add them up is you put them tail to end. So first, alright, so let's have our first vector, which is this top one, which is going to be 1.25 v there. And it's going to be at a 30 degree angle of east, which is just a line. We're not sure how long that line is. And then this other angle, what we're going to do with this angle right here is we're just going to put it right here. We've just moved it and put it right here, tail to 10. So they are linked right there. Now you'll notice that if this is our east, adding these together will get us on this eastward vector, adding those together. Now, another question you might have is, where is theta in this problem? Well, let's think about this. So normally, if we had, theta was right here originally. So let's just kind of imagine an imaginary line right here. Theta was here. But now, this was going east, and this bottom line is going east as well. So these two are parallel. So now this right here, this is also theta, because due to our angle property laws. So now what we have here is we have a nice triangle right here, actually, which we then can use our triangle knowledge to then solve this problem. I love using triangle knowledge, don't you? Alright, so let's solve this. Okay, so the way we're going to solve this is we're going to use the law of sines. For those of you who don't remember the law of sines, the law of sine is basically, if you have a triangle, any triangle, like this, say, and you have for points A, B, and C, and then A, B, and C, so B, B, they're across from each other, C, C, blah, blah, blah. The law of sine states that sine A over A equals B over sine B, which equals C over sine C. So that's the law of sines right there. So we're going to now use that in order to solve this problem. So I'm going to go down a little bit. All right. So the way we're going to solve this is now, so we know now what A, B, and C is. So we're just going to A and B are. We have an A and B. We don't need the third one. So let's start plugging this in. So let's set A is equal to 1.25 V. Okay? And that's over, the angle across from that is going to be sine theta. Okay? Sine theta. And that is going to equal V over the angle across from that, sine 30 degrees. Sine of 30 degrees. Okay, so now we have a nice equation. And now we have to solve for theta right here. So how are we going to do that? Okay, well now we can do some canceling right here. We can cancel these V's on the top, which is nice because, yeah, we can cancel them because of canceling laws. And now we can just solve this. So let's so we're going to multiply this out. We're going to multiply both signs by sine of theta, so we get 1.25 equals sine of theta times sine of 30 degrees. Can't forget that degrees. Don't want this to be in radians. And then we're going to divide both sides by sine of 30 degrees, and we're going to get 1.25 of sine of 30 degrees equals sine theta. And now, using that, we can then turn that into theta equals inverse sine of 1.25 over sine 30 degrees. And there you have it. And now we just use our handy dandy calculators to solve that out. And we get theta equals 338.7. 30 is going degrees, and now degrees where? It's asking for a direction, so let's go back up here to our original problem, our original diagram right here. If this is east, it's going to be 38.7 degrees south of east. So we're going to go down here, back down. Oh god! So our answer is 38.7 degrees south of east. And there is our answer. Now we don't need to find V. We could just need to find our direction, and we have solved it here using law of sines by reorganizing the vectors. This is the important part of this question. It's just remember that vectors can, this right here, this diagram right here is kind of what you want to this what you think this is going to look like, because you have kind of these two tugboats right here kind of going in opposite directions, and they're pulling another boat. They're pulling another boat right here, and so you're thinking, oh well, that's the diagram because those are the vectors, and that's pointing that way. But you have to remember that that's misleading. You can't really do anything with that right there, at least not easily. So you have to remember that you can reformat the vectors and put them in different spaces. In this case, adding them together, you put them head to tail. You create the resultant vector, and then you can find the angle from that. So you just have to keep in mind that vectors can be kind of confusing because they're not quite line segments, but they actually have more freedom in some ways than line segments, and thus are in some ways actually easier than line segments, though in some cases they do get a little bit annoying. But yeah. Anyhow, okay, so that was our problem 17 from 13.2. Hope you guys enjoyed. Keep cool out there. Enjoy calculus, and we'll see you guys next time.